Om Gange cha Yamune chaiva Godavari Saraswati Narmade Sindhu Kavare Jalesmin Sanidim Kuru. This is the first major chant of every puja, which invokes the life-giving waters of the 7 sacred rivers of India into a vessel that's going to be used for the worship. Now, what I thought was particularly, what I appreciated very much about Swami Shraddhananda, who some of you may recall, he's passed away quite a while ago now, but is that he used to substitute the 7 great North American rivers, the Mississippi, Missouri, Rio Grande, St. Lawrence, Columbia, Red River, Colorado. Those are the ones that I find as being, like some of the largest rivers in North America. I want to start on a sort of a personal note. I have been aware of the preciousness of water from a very early age. My grandmother lived on the shore of Lake Huron, which is technically designated a marsh most of her life. Yet she did not have a source of potable water and had to have it brought in every week from the town's waterworks. In the basement, she had a cistern for captured rainwater, which was used for toilet flushing and bathing only. So from the beginning, she taught me to conserve water, use only what's absolutely necessary to get clean, and share whatever is left with animals or plants. And I still do this. The drought in California, it has been a constant reminder of the fact that all beings need water. It's an act of respect and a kind of worship to share water in this way. I'm not saying other people don't do this. Of course, people in India offer water to trees, etc. This is a kind of a universal thing. But it springs from an acknowledgement of some kind of a relationship with other beings. Where my grandmother lived, the entire eastern horizon was given over to a great expanse of water. It dominated the entire environment and was a source of endless engagement for kids. There were patches of sand left from the last glaciation with sedges and cattails in standing water. Plus, for real entertainment, there were tadpoles and endless things to learn about fish, migrating water birds, and muskrats, to name a few. Consequently, of all of the 5 great elements stipulated in both Eastern and Western ancient philosophy that are necessary for life, this is my favorite. So let's take a look at the story of water on our planet. In the same way that you are a mystery, so is water. Swami Vivekananda said that if you go deeply enough into anything, you find it disappearing into the infinite. So we're going to cover a lot. Briefly, the trajectory of this talk. We'll start with the molecule, then its physical properties, then the prevalence on the Earth, and then switch into an Eastern and metaphysical mode, and then transition into some mythology before examining the phases of water in greater detail. And finally, we'll look at some relatively recent discoveries about water and try to delve into the meaning of those discoveries. Now, this is obviously a broad brush because you can't cover that kind of thing, all of that stuff, that quickly. So here's the molecule that we're all familiar with. It's very simple. 2 hydrogen atoms grab a single oxygen atom. This simple structure leads to a kind of interaction between water molecules known as hydrogen bonding, in which the opposite charges attract each other. The physical properties of water are that it exists on Earth in 3 phases, we are told. It is solid under 0 degrees centigrade, liquid at standard temperature and pressure, and vapor over 100 degrees centigrade. Water, we all know this, I'm just reminding us, water is tasteless and odorless, and it is transparent in the visible part of the electromagnetic spectrum. Water has properties that in many cases break the trends observed for other simple liquids. Water expands, for instance, one of the things that's different, in its solid phase, exactly the opposite of most substances. So a fixed mass of water takes up more room as a solid than as a liquid because of the way its molecules form a specific regular structure. Water can act as either an acid or a base. There aren't many substances that can do that. Therefore, it's called a universal solvent. Another property is the surface tension of water, which is roughly twice that of other nonpolar, simpler liquids. We'll see that in a second. Quote from one scientist, "Even the most familiar substance still has secrets hiding within." So water is made of the first and third most abundant elements in the universe. Owing to the electronegativity difference between the hydrogen and the oxygen atoms and the bent shape of the molecule has a more negative side and a positive side. And this figure indicates the partial charges that the atoms possess. But sometimes deuterium, which is a slightly heavier version of hydrogen, weasels its way into the mix. The nucleus of a deuterium atom contains one proton and one neutron, whereas in regular hydrogen, the proton stands alone. On Earth, about 156 parts per million molecules of deuterium are the norm. So remember this thing about deuterium because we'll come back to it in a couple of minutes. The structure of molecules in water is rather random, and in ice is highly structured. Some of the other properties that come into play are the fact that it flows downward. Water always takes a downward course. This has tremendous implications for engineering, that is, getting water to work for us. So we could go on and on about all kinds of inventions that utilize these unique properties of water. Also, water is very heavy. 1 gallon weighs 8.3 pounds. Very heavy. The other properties that are important, it's cooling, it's cleansing, it's shapeless, it's containable. Now, because of these last few properties, the shapelessness and containability, according to the Sankhyan system, which we'll talk more about a little bit later, in the process of cosmogenesis, water is considered proto-matter because it's not broken into distinguishable pieces. It's homogeneous throughout, everywhere on the planet. It's exactly the same. If it differs at all, it's because of the impurities that are in it, not because of the water itself. So here's an example of surface tension. This is a very important quality of water because this helps it move through roots and capillaries. It's vital to sustaining life on Earth and is virtually incompressible. So the entire applied science of hydraulics is based on this aspect of water. A hydraulic fluid or hydraulic liquid is the medium by which power is transferred in hydraulic machinery. So again, another engineering application. You know that you've probably all seen at some point insects that can walk on top of water, or small lizards even sometimes do that. This is because of the high surface tension, which means that the molecules of water would rather adhere to themselves than to anything else. So here's a single drop. You take a drop of water and you drop it into water, and what happens is it bounces back out. A drop bounces back out. The surface tension is what makes it do that. It doesn't just flow, and also I presume the weightiness of it. It doesn't just disappear immediately. No, it always flows back up and then back down. So this fluid motion is important, and despite being the most ubiquitous and important liquid on Earth, water is a deeply puzzling substance with physical properties that deviate significantly from those of an idealized liquid. Several theories have been advanced to account for some of water's idiosyncrasies, but experimental data have been lacking until fairly recently. Recently, people have actually been delving into this. So let's just talk about one aspect. For instance, supercooled water. That is, the temperature is below freezing, but it remains a liquid. This is notoriously difficult to study. Solid ice is the most stable phase of water below 0 degrees centigrade. But the liquid phase remains what they call metastable at sub-zero temperatures. Under normal circumstances, impurities such as dust particles provide a focus for the ice crystals to form, so freezing occurs very quickly. But in the laboratory, where you can have very purified water, you can bring the temperature down much further, and the molecular motion slows down until it begins to freeze at about -40 degrees centigrade. So this shows, as I'll mention again a little bit later, that water doesn't really have a fixed temperature to change from one phase to another phase. It depends completely on so many other factors, pressure, etc. At sufficiently low temperature, liquid water normally crystallizes into ices with cubic or hexagonal symmetry. We showed the hexagon a little bit earlier here. But a simulation study now shows that this occurs through a precursor stage which has tetragonal symmetry. I mean, like a square, like a cube, okay? This explains why water is unusually pressure dependent, because in order to get to the homogeneous crystal nucleation at a given temperature, it has to go through a whole different phase, I should say, structure. So freezing water is an amazing thing. I attempted to, I tried to find, I don't have audio here, but I wanted to have a picture with the audio of what it sounds like when in the far north, the ice on rivers break up in the spring, or what the glaciers sound like when they calve into the sea. I mean, the sound is just unbelievable. But instead, we're going to look at the planet from above. When seen from outer space, our planet looks blue. How did all this water get here? At the beginning of Earth's formation, heat from the young sun vaporized any ice that dared to come near the inner rocky planets. Some scientists argue that Earth's relatively feeble gravity at that point in time couldn't grab onto the water vapor or any other gas for that matter. So the water must have come from outside later, the astronomers argue. But we know, because computer simulations indicated, that the bombardment of asteroids a few million years after the start of the solar system could have easily delivered enough ice locked in the rocks, safe from the sun's heat, to account for Earth's oceans. Over vast periods of time, our primitive oceans formed. Water remained a gas until the Earth cooled down below 100 degrees C. At this time, that is about 3.8 billion years ago, the water condensed into rain, which filled the basins that are now our oceans. But some physicists think that comets were the method of delivery for water to the Earth. Part of the problem with this theory lies in the chemical difference between water on Earth and water in most comets. So here is a picture of regular water and heavy water. Deuterium, which we mentioned before, also called heavy hydrogen, is an isotope of hydrogen with a nucleus, as we said, consisting of one proton and one neutron, which is double the nucleus of an ordinary hydrogen. Therefore, heavy water, on the right-hand side, is about almost 11% denser than normal water. So if you put an ice cube, a regular ice cube in regular water, it floats. But if you put an ice cube made of deuterium, it sinks. Now, in 2010, they're looking at this deuterium element or factor. In 2010, researchers measured the deuterium-hydrogen ratio of a comet whose water nearly matched that found on Earth. And similarly, in 2013, they also found one with abnormally low deuterium-hydrogen ratios. So suddenly, possibly 2 comets were carrying Earth-like water. So they thought, oh, great, this is evidence for our, theory that the water came from comets, crashing into the Earth. But then in 2014, the European Space Agency's Rosetta probe arrived at another comet. And the spacecraft sampled the water streaming from the comet body and found that the deuterium-hydrogen ratio was more than 3 times that of Earth's oceans. So this calls the comet source hypothesis into question. Volcanologists dismiss all of this. They say that water's been here all along, and the volcanoes actually brought it up from the inside in the form of vapor for hundreds of millions of years, and it rained that whole time. So the question of the origin of water on Earth is still unresolved. The fact is, however, that we've got a lot of it, at least it seems like that. This is a picture of how the deep water ocean convection currents operate across the entire globe. It's an endless loop. It's called a pump because the salinity moves from the more saline at the deeper depths to less saline nearer the surface. Earth is a planet that basically runs on water. And 40% of the world's population lives within 100 kilometers, so say, what is that, 60 miles of any coast. So that's one big loop. Most of us inland here are not aware of that. We don't think about it so much. But the next one affects our weather system all the time. So this is called the hydrologic cycle. Water regulates the climate, shapes and reshapes the landscape, and is essential to life. It's a closed system, both of these diagrams. Therefore, the very same water molecules that may once have passed through any great figure that you can name, maybe Holy Mother, have passed through you also. All right, so we saw the whole planet as a whole, and it looks very watery. Now let's break it down. Where is Earth's water? Well, okay, 96.5% is in the oceans, and then there's a tiny little line at the top, 0.9% is this other saline. That would be things like the Great Salt Lake or the Dead Sea in the Middle East, places like that. And fresh water is only 2.5% of the total amount of water on the planet. So you see this line to the right that goes off to the right. We're going to take that 2.5% and we're going to break that down into what kind of fresh water? Okay, almost 69% of the fresh water that we have is locked up in glaciers and ice caps. Then we have other kinds of groundwater that would and then finally there's other surface water, which is 1.2% of that 2.5% that we started with. Going further, if we take this surface water, this other fresh water, and we break that down, we find that, again, ice and permafrost account for 69% of it. Lakes are less than 21%. The atmosphere is 3%, but look at this. Rivers are less than 0.5%. Swamps and marshes, there's a lot more in swamps and marshes, 2.6%. And living beings are 0.25%. And that includes plants. So this is where the water is. So how much water is there actually? See that little blue ball up in the left, upper left? That's how much water totally there is on the planet. Let's label it. That ball is 860 miles in diameter, and that's 100% of Earth's water. No, all water, ocean water, everything. The second little ball is 170 miles in diameter. That's the fresh water. And the third one, can you even see it? Which is 17 miles in diameter, is just the surface water. That is the fresh surface water, rivers and lakes. So, frankly, folks, Earth is positively parched. Despite having more than 70% of its surface blanketed in water, water accounts for only 0.023% of the planet's entire mass. We've been hoodwinked into thinking it's plentiful. Okay, I want to shift now from this sort of structured scientific kind of a thing to a more maybe Eastern philosophical symbolic angle. And I would like to begin with an excerpt from the Nasadiya hymn of creation from the Rig Veda. Excerpts, I should say. Quote, "There was neither non-existence nor existence then. There was neither the realm of space nor the sky which is beyond. What stirred? Where? In whose protection? Was there water bottomlessly deep? Darkness was hidden by darkness in the beginning, with no distinguishing sign. All this was water. The life force that was covered with emptiness, that one arose through the power of heat." Which, by the way, coincides exactly with what we know. First the planet was hot, then we got water. Okay, so let's look at the second chakra from the bottom in the Kundalini system. That would be, this is what is normally depicted as, with the Vam Bija in the middle. The other system, another system, which is the five sheath system, would put water in the Pranamaya Kosha, or the second sheath. It's associated with the breath of life, but also feelings and the unconscious. That is, retentive, primitive, sort of instinctive mind. According to the most ancient Sankhyan cosmology, when you're talking about how things came from the most abstract to the most concrete, water is the fourth evolute, or Mahabhuta, or great element of Prakriti, or nature. The word Sankhya itself means simply enumeration or classification. The ancients wanted to examine everything that exists and make a meaningful system of that, so that nature could be better understood and ultimately transcended. Within this Sankhyan system, there's always correspondences. So on the perceptive side, water is associated with the sense of taste. And we know the word is rasa that they use. We know that traditionally there are 6 types of taste: sweet, sour, astringent, bitter, salty, pungent, and now lately they've added a new one, umami, which is the 7th, and that is generally defined as being something that's a little more related to sort of something that's been cooked, charred, like that it has a particular like smoky flavor. Okay, that's you'll see burgers being marketed nowadays as having umami. Okay, anyway, so on the active side, that is, if you look at the organs of action, it's associated with the generative organs, water. For the ancient Sankhyains, meditation on the great elements meant, after various preliminary steps, meant coming into direct union with the element itself in a sort of savikalpa samadhi. Even though they called it a great element, they understood that what they were dealing with was really an idea, a concept, not a physical thing at all. This kind of practice was preparatory for them for ultimately merging into the absolute as they ascended the meditative ladder through the other elements. Universally, water is a symbol of purity, fertility, life, motion, renewal, and transformation. The profound symbolism of water comes from its 2 vital qualities. It is most essential for existence, and it cleanses and purifies things by washing away impurities. Its power of transformation from liquid to solid and vapor also make it special and a symbol of metamorphosis and recycling. Sprinkling of water in religious ceremonies is global. Almost all religions have some form of shanti jal type of thing. For Muslims, which on the left-hand side, ablution with water, what they call wudu, is an obligatory preparation for daily prayer before they enter the mosque. There's baptism in Christianity, which initiates one into the Christian tradition. And then in Hinduism, daily bathing is a sacred act, and the contact with water begins any sacred act also. For example, to make a sankalpa, that is a stated formal intention. You need water for that. And achamanam, which is sipping of water before reciting the Vedic texts or any spiritual texts. So if we, nowadays, here and now, genuinely hold that water has intrinsic value, it will be demonstrated in how we act. Our actions will express a spirituality of respect for Earth's water resources. Conversely, if we routinely act in ways that misuse water, we will display an inner spirit that lacks respect, regardless of what we may say about the value of water. Therefore, paying attention to how we act puts us in closer touch with our operating spirituality. Greater awareness of our inner spirit helps us identify the strengths of our true convictions. Now, this example kept coming to mind, and I said to myself, yeah, but does it really fit? I don't know, but I remember it a lot, so I'm going to bring this to mind. I'm going to explain this to you. Perhaps we get an inkling of a deeper connection in one scene of the theatrical production of The Miracle Worker. How many remember The Miracle Worker? Oh, well, good. At least some people know what I'm talking about. Here, the teacher, Anne Sullivan, works with the deaf-blind child, Helen Keller, who is now about 8 or 9 years old, as far as I recall. And Anne is attempting to trigger awareness that things have names with this child, this deaf-blind child. We see, after much work on the part of the teacher, how the child finally awakens to this identity of name and thing when the teacher forces her hands under a pump and pumps water. As the water gushes out, Helen's mind finally sparks and she reaches back to a memory from when she was 2 years old, before she lost her ability to see and to hear. And her face lights up and she exclaims, "Wow!" And she makes this primal connection. And now, this isn't just a water thing, but she knows names and things are connected. Here's a mythological image. Markandeya's vision of the innocent baby preserver of the world, the all-pervading, all-knowing one, Vishnu, floating on a leaf in the ocean of consciousness before the sprouting of thought. Many, you can find them, I've only got a few here, spiritual masters echo this theme. So for instance, Jesus says, "Unless you become as little children." Ramakrishna always extolled what he called guilelessness. Straightforward, no complexity, directness. In Zen, we talk about beginner's mind, the mind where everything is new and fresh and there's no interference from anything that we've maybe misunderstood before. And Sri Nisargadatta talks about Bal Krishna mind. That is the baby child, which is exactly what's depicted here. The child before the sprouting of thought. Many archetypal heroes are as if born of the water, such as Moses, who was born in a very lowly family, but then raised in a princely state. And then the opposite, Karna from the Mahabharata, who was born very high. He was born a prince, but he was raised by lowly people. And in both cases, these babies were found floating on a river and raised by someone directly opposite of the child's origin. There's one such hero, there's millions of stories, but one such hero that probably does not leap into mind is Hiawatha, who was a Mohawk Indian chief, or possibly the leader of an Onondaga tribe, depending on whatever source you look at. He was attributed with having joined together 5 tribes to form the Iroquois Confederacy. He's believed to have been born around 1525, but not much is known about him prior to becoming a chief. He was an explorer, statesman, and spiritual leader. A generation ago, that means before me, I don't mean a generation ago from now, I mean a generation prior to me, there probably wasn't an American who did not know the story of the great native mythical hero of the Great Lakes region, because it was actually taught in schools. Now, one episode of this story is that Hiawatha went looking for the great fish, the gargantuan sturgeon. You know, some fish never stop growing. In order to conquer it, for whatever reason, I don't know. But anyway, in the battle, the fish swallows both the canoe and Hiawatha. Okay, you see up here? See the squirrel up there on the end of the canoe? The squirrel is his companion. And the description is, as the canoe goes down, see here, no, the other thing I wanted to point out here. The sturgeon he's looking for is not this. It's this. You see that? He's looking for the gargantuan sturgeon, okay? And as the sturgeon grabs the canoe, the description is, the canoe goes upends like this, and the squirrel is sitting on the top, and the sturgeon gulps it down. So it swallows both the canoe and Hiawatha. To make a long story short, eventually, somehow the seagulls free Hiawatha by pecking through the carcass of the fish. And After sharing the remains of the fish, Hiawatha goes on to his other great adventures. So that's a little bit about Hiawatha. Now, a few sort of little miscellaneous things before we get to the next major thing. We have the moon's influence on tides. People who live along the coast, fishermen, seamen, Polynesian explorers were the greatest explorers. We never hear about them. But they dealt with the Pacific Ocean, the largest body of water, and they found every conceivable habitable island that there was out there. Moon exercises control over the mass of water on the planet, and by extension, for the ancients, anything that is of what they call a watery nature, which would include living beings. So the association between the moon and water is primordial. Look at, for instance, the Ayurvedic system where we have the three doshas, and the kapha dosha is the watery element. So it's been built into medical systems for a long time. We'll see soon how new discoveries seem to corroborate this ancient knowledge. Now, just for the heck of it, I wanted to show you, this is the tidal bore on the Amazon. This is the influence of the moon on the water. This is not sand, this is water, okay? And those little dots that you see on the first line are people who are surfing. There's a story in the Gospel of Ramakrishna about how the tidal bore was about to come up the Ganges. And so he called everybody and said, come, look, let's watch, let's see. And then remember he said something, oh, I wonder if that boat's going to survive. Because, the water was rushing up the Ganges. In South America, Colombia specifically, the Kogi people who live way up in the Andes, they commune directly with water through the bubbles. Through bubbles. It's a combination of visual and auditory, I think, because they say to think is to listen. They're listening to the water. I'll mention them again a little bit later. Here we have simply another natural phenomena in association with heat. We have geysers, and everybody knows that forever, just about hot springs have been associated with healing all over the planet. Water has an irresistible attraction when it's running water. It connects us to our own inner hydraulic system. I'm almost convinced. Okay, so let's talk about how red blood cells carry oxygen, which is required for our heart to beat and our brain to function. This is all an inner hydraulic system that we have. The white cells defend us against invasion by lethal pathogens. The platelets and the proteins in plasma form clots that can prevent fatal hemorrhages. Blood is constantly being renewed by stem cells from our bone marrow. Red cells turn over every few months, platelets and most white cells every few days, but it's all conveyed by water. Blood travels in the body every day 12,000 miles. Our network of veins, arteries, capillaries is about 60,000 miles long, twice the circumference of the earth and more. But we contain only about 9 to 11 pints of blood. That's much less than 2 gallons. In India, rivers were taken to be sacred, and their confluences even more so. These are places of pilgrimage. Similarly, in Africa. In Brazil, the Amazon River carries more water to the sea than any other river in the world. So I'm talking about flowing water here. In Europe, it seems that springs were the most often deemed sacred. In Ireland alone, there are 3,000 of them. This spontaneous gushing of water is usually related, again, to healing properties. And these become places of pilgrimage, places where people go to pray. In the Middle East, there's the Jordan River, and on the Arabian Peninsula, primarily, it's a matter of wells. Remember the story of Jesus and the woman at the well. In North America, for the First Nations, all water was sacred. In South America, they have, at least in one portion of South America, primarily the Yucatan Peninsula, they have cenotes, what they call natural limestone cisterns. There are a few in Central America also. Over 2,200 cenotes have been found, and many have had in the past, cities built around them, complete with stairs and pathways down. You can see the pathway on the right-hand side, the stairway going down to the water. The Mayans offered items to the gods there because the humans depended on this sole source completely for themselves and their fields. And of course, now we know that a large part of the collapse of the Mayan empire had to do with the drying up of the cenotes. Similarly, also here in the U.S., the Anasazi people down in the border along Mexico and the U.S., in the desert areas there, their civilization was probably, what can we say, eviscerated by an extended period of a lack of water, and so they disappeared. Now, frozen water, just because I love these pictures, I just wanted to point out here. Up in the upper right, that's steam, actually, rising off of a frozen lake or stream. And then we have hoarfrost on the upper left. Hoarfrost is just vapor that freezes onto physical objects when the temperature is just right. And of course, icicles and snow on a tree, as here. Some more trees covered with snow. Earth sleeps at this time. Peace, peace, peace. Some of you may have heard of this. There's a Japanese investigator, researcher, who looked into the microscopic side of water, and he says there are hidden messages there. I've only got a couple here. There's books full of these things, pictures that he's taken. What he does is he takes the water from whatever source he wants to investigate, flash freezes it, finds a single crystal, and then photographs it with an electron microscope. So this particular one has been exposed, the water from which this crystal came has been exposed to the music Edelweiss, from the sound of music. This one was exposed to a photograph of cherry blossoms. How long that exposure is to the photograph, I don't know. Now this one, in an unspecified Buddhist country, this is the crystal that came from a particular water behind a dam, a man-made dam. Something is severely wrong. So we've done all kinds of things to water, and one of the things that's coming up now over and over again is the privatization. I don't know if you're aware, but the privatization of water here in California is astounding. They've been preparing us for this, though, for quite a while, by getting us used